Okay. Sige, later ko na lang siguro i-upload. Okay. So I have, let me see. Pumasok. Sorry. Aking alaga eh. Naglalambing. Kinalmot na naman ako. Anyways. Okay. So yeah, it's already uploaded on your TBL Hub regarding the mechanics for the photo contest. So you have also the links there. So feel free to reach out to me if in case you're interested. Sayang din yun. Now, I'll also be giving out points for you guys if in case you wish to participate. So pag nag-participate po kayo, you're gonna be given additional 10 points or 5 points on your midterm exam. Okay? And then if in case you win, it's I'll give 1 point on your grade. Okay? Grade na yun pag nanalo ka. Pero kung hanggang qualifier lang, 5 points sa major exam. So it's gonna be either midterm or finals. Okay? Wait lang. Kasi baka magsulat ako mamaya. Forward ko lang yung screen ko. Okay? So yan. Okay, so let's start with the discussion about lipids. Okay? So, lipids is actually a class of biological molecules which are actually nonpolar or highly insoluble in nonpolar solvents like chloroform, but insoluble in water. Okay, we might say it is water-hating compound. Okay, so usually it's made up of hydrocarbons. That's why it's usually um, reacting inside the body. It's also oxidizes in metabolisms. It gives also a lot of energy. Now, examples of lipids are fats and oil. Okay, so usually it depends on the room temperature. Pag solid siya, you will say fats. If it is liquid, you call it as oils. Okay. Then you also have vitamins. By the way, there are four vitamins that are fat soluble, which is ADEK. ADEK. Sulat natin. Okay, ADEK. Vitamin A, D, E, and K. So those are all fat soluble vitamins. The rest are water soluble. And then you have most hormones. Okay. Then you have also one of the functions of lipids is non-protein membrane component. So it's part of the cellular membrane. Now, usually when you see lipids, it's usually getting a connotative idea that it's bad for your health. But it is not that bad. It just so happened that depende yan sa paggamit natin. Lahat naman ng gamit na i-abuse natin, it will have a negative effect on our body. Okay? So, nasa gumagamit yan. Now, but it is important because it's part of the metabolism and also of our cell structure. Okay? Pag tinanggal mo yun, di wala tayong cell membrane niya. Okay? Wait lang. Hala. Ano ba yan? Wait lang guys. Nagkaroon tayo ng ano, bili tayo ng ano, wireless chauvinist. Wireless headset. Wow. Yamanin. Okay. Yan. Okay. Now, going back, this is actually the class of our lipids. So the lipids are actually further divided into wait, yan, to fatty acids. So pag simplihan, you have fatty acids, then you have the glycerides, then you have your non-glyceride lipids, and then you have also the complex lipids. Now, we will be discussing all most of this later on, okay? So yan, so yung different types of waxes, phenolipids, steroids, yan. Then you have also the lipoproteins. Okay, so let's talk about the, so I'm just gonna jump on this one kasi di-discuss din natin yan later on. So unahin muna natin yung pinakasimple. You have your fatty acids. So these are the basic building materials of your lipids. Now, it usually forms triacylglycerols or tags and phospholipids. Now, it's actually made up of three parts. So you have here, okay, so take note that you have here carboxylic end, then yung chain, and then your methyl. Now, your methyl is your omega, and this is your alpha. Okay? So, yun ang tatandaan ninyo, the parts. Now, another thing to remember about lipid or fatty acids, it is actually your carboxylic acids with a long hydrocarbon tails. Now, most of the time, it is not, it is usually combined with other compounds, okay? Except for arachidonic, which is gonna be free. When you say free, it's a fatty acid existing outside, okay? Now, take note that your lipids are usually esterified. When you say esterified, it forms an ester with other lipids to form major components of other lipids. Okay? So remember, ester is RC double bond OR. Okay, so that's an ester. Now, commonly used ang fatty acids in triacylglycerols or tags. Now, the number of carbons may be from 40 to 26, but usually it's even. Pero may mga add tayo, pero majority ay sa environment ay nasa even siya. Okay? And concatenation of two carbon units ang pagpapahaba ng fatty acids. Now, we will discuss this particular part, itong concatenation, during our topic metabolism of lipids. Okay? Now, take note that C16 and C18 are the most common fatty acids in plants and animals. Okay? Later on, we will be discussing some of it as we go along. And then, the double bonds on our fatty acid usually varies from one fat double bond to four. Okay? Yung iba mas marami pa. So, majority is hanggang apat lang po yung bilang. But mostly in bacterias, um, bihira po yung one. Sa kanila marami silang double bonds. Okay? So let me just go to the next slide. So the next slide shows you some of the double bonds. Sorry, not the double bonds, but fatty acids. Okay? So these are examples of fatty acid. You have stearic acid, yan. And then you have your oleic acid here. Okay? So ito si stearic. Ay, wait lang guys ha. Nag-restart. Yan. Okay, going back to this one, share ko ulit. So, patayin ko yung camera, ang laki ng mukha ko. Okay, going back to this one. Kasi sabi ko kasi sa inyo, nagsusulat ako doon sa screen ko. May parang touch screen yung sa laptop, kaya pag masyadong malapit sa mukha ko, laki na tuloy ng mukha ko sa screen. Anyways, going back to this one, so you have here your oleic acid, you have your linoleic acid, you have your alpha-linolenic acid, okay? And then, if you're going to look about this, take note of the double bonds. Okay, yan. Now, in terms of length, okay, you have what we call short chain fatty acids. Now, pag sinabing short chain, it's usually 2 or 4 carbons lang siya. Now, because of the length, it causes them to have a weak interaction. And short chain fatty acids are usually liquid at room temperature. Now, you have also 6 to 10 carbons, which is categorized as medium chain. And the other one is the long chain fatty acids. Now, pag long chain, it's 12 and above yung carbons niya. Now, this is the most common type of fatty acid that's found in foods. And because of the long chain, they cause this to come, ano ba yun, nagkakaroon sila ng strong attraction to one another due to the polarities, di ba? Like dissolves like. So, non-polar, mas mataas ang attraction nila with other non-polars. And that is the reason why it tends to become solid at room temperature. Okay? Now, in terms of saturation, the concept of saturation is still the same when we talk about saturation in organic compounds. Di ba? Pag sinabi saturation, usually it's single bond, and it has an impact with the type of bond that is the type of characteristic. Therefore, it's usually solid at room temperature because it has a higher melting point. Now, unsaturated because it has double bonds instead of single bonded. So most of the time it is classified depending sa number of bonds. So if you have also monounsaturated fatty acids, when you say MUFA or monounsaturated, you have only one double bond found. Okay? So isa lang yung double bond natin. Then you have also the polyunsaturated fatty acid or called the PUFA, which has two or more fatty acids, and double bonds, sorry. Now, take note that unsaturated are usually liquid at room temperature because of lower melting point. Okay. Now, this time, this is the same compounds that we talked earlier, but this time, if you will notice, kinonsider na ngayon yung kanilang type of bonds inside. So here, if you will notice, meron tayo here, all of them are 18 carbons. Okay. So mapapansin niyo it's identified, labeled carbon number 1 to carbon 18 for every compound. Okay. Now take note, oleic acid is 18.1, while for linoleic it's 18.2, and linolenic is 18.3. Now, ano yung ibig sabihin nitong 18.2, 18.3, 18.1, and 18.0? Now, this is actually based on the number of unsaturation. When you say unsaturation, again, it's the double bond. Gaano karami ang double bond niya? So, for example, si unsaturation, this is not supposed to be oleic kasi ang oleic is, tama, oleic is double bond siya, isa. If you recall here, ayan siya. Okay? Systeric pala nasa isip ko. Okay, so here, you have oleic acid. Now, it is unsaturated, has one unsaturation point or unsaturation bond, okay, or double bond. And the next one is where it's supposed to be, carbon number 9. Okay, so it means yung sa magkatabi, number 9 and 10, doon nandoon yung double bond. Okay, or the double bond starts at carbon number 9. So this is how it's usually is being counted or usually presented. Okay, now if you're going to condense it, this is how it's going to be written out. So it's going to be showing here as CH2, open CH2, 7, close 7, then CH, double bond CH, open CH2, close 7, COOH. Now, ano ibig sabihin nito? So, between the methyl and the first double bond, you have 7 molecules of CH2 in between. So, since magkakapareho naman yung mismong mga ito, pinag-condense na lang sila ngayon. Then here, so instead of writing it as CH3, CH2, 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 hanggang makabot ka ng CH7, o pangwalong CH7, ganon. Kinondense na siya. Okay? By getting the empirical formula and how many times that empirical formula showed up. So, ganon din sa kabilang side. So, you have there the CH kasi sa inyo double bond, and then ilang CH2 yon kinondense to have this form. And then the carboxylic end, which is COOH. Okay? Now, later on, you will go into this part, yung conformation. Okay? Yeah. Now here, this is actually the reason why it is kind of bent because of the double bond. So since there's a double bond, it's causing it to bend at 30 degrees. Okay, usually it's 30 degrees. And then here, showing again, 18 carbons, one double bond at carbon number 9. Okay, so this is what it means. And then, here, citric acid, if you will notice, it's straight. Ibig sabihin, wala siyang double bond. As you can see here, it is 0. Okay? Yan. Now, this is the reason why it is easy for them to combine together. Kaya papansin nyo, saturated acid, fatty acids are solid because they tend to aggregate on one another. While for unsaturation or unsaturated fatty acid, they are kinked or bended, kaya hindi sila masyadong nag-aggregate. Okay. Now, here are examples of your fatty acids, space-filled model, straight chain or saturated. You have arachidic, stearic, palmitic. You have erucic, oleic, arachidonic, linoleic, and linolenic. Okay? So, yan. So, yun yung bibigay ng structure niya kung bakit siya nakabend. Now, on this slide, it is showing your different fatty acids, okay? So here, showing the number of carbon atoms, okay? And if you notice, this is the condensed structural formula. And then look at the melting point, okay, in terms in Celsius. So as you notice, as the number of carbon increases, the melting point also increases. So if in case we have carbon 50, if in case that we have carbon 50, baka nasa 200 na siya. Okay? Then here on the bottom, you have here your unsaturated. Okay? So here, unsaturated palmitic acid, you have one unsaturation, negative zero point 0.5, kanyang melting point. Then oleic acid, 18 carbons, one unsaturation is 12. Now, if you compare oleic from linoleic, which has two saturation points, okay, it has changed dramatically. So from 12, which is oleic acid melting point, it's now negative 5. Ito nung dinagdagan natin, you have alpha linolenic acid. Tatlo yung kanyang saturation points. Okay? So you have there negative 5. Okay? So if you will notice, regardless kung alpha siya or gamma, it's still gonna be the same melting point. Okay? Then here, you have four uh, unsaturated points. You have now melting point of 49.5. Okay? Then EPA, yan, eicosapentaenoic acid, eicosapentaenoic acid or EPA is negative 54, while DHA, di ba alam niyo yun sa narinig sa advertisement, is has 6 is negative 44. Okay? So yan. So take note of the number of double bonds, number of carbons. Okay? Yan. Again, the lower the amount of saturation, the lower the melting point. Okay, this time we're going to be talking about fatty acids with different bond location. Now, we have actually two types of systems in locating the double bonds in a fatty acid. We have what we call the gamma. Ito po yung gamma, which, sorry, not gamma, but omega, and then the alpha. Omega is the end, alpha is the beginning. So if a system, if it is written there, the name of the compound or the fatty acid, pag wala po siyang alpha, it means that you're starting from the carboxylic end. Pero kung if identified like omega-3 fatty acid, you start with the omega end, yung pinakadulo. So here, we have omega-3 fatty acid. So the first double bond is between the third and fourth from the omega end kasi nga omega-3 siya. An example of an omega-3 fatty acid is alpha-linolenic acid, okay, which is one of the two essential fatty acids. Then the other one is omega-6. Now, omega-6, the double bond niya is between the 6 and the 7 carbon from the omega end. and that is linoleic acid, which is the other essential fatty acid. So omega 3 and omega 6 are the two essential fatty acids. So if you're going to draw here, or if you're going to get the structure, ito yung alpha end, which is the carboxylic part, and this is the methyl end, which is the omega part. As I mentioned earlier, the parts, ha? Alpha and omega. So, 3 carbon, omega end. So, 1, 2, 3. Kaya ito po siya. Then, omega 6. Okay, so 1, 2, 3, 4, 5, 6. So, yan. So, this is linoleic and alpha linolenic acid. Okay? So, yan. Okay? Then ito naman po in terms of shape. So sabi ko nga sa inyo kanina, because of the kink, it tends to affect the shape of the fatty acids. Now, it's actually based on the conformation of your double bonds. Particularly saan nakaplace yung hydrogen ninyo. Now, if both hydrogen are on the same plane or yung same side, you call it as a cis form. Okay? Yan, parang sisters. And then the other one is trans. It is transverse, hindi transformation ha. Transverse ang ibig sabihin niya. Kaya transform. Okay? So yan po yan. So hydrogens that are on the opposite side are considered as trans. Pag nasa same side, it's called as a cis. Okay? Now, your fatty acids tends to spoil also. Napapanis din yung mantika natin. Now, usually this is caused by the double bonds. The more double bonds that you have in your fatty acid, the higher the chances of becoming rancid. Di ba yung minsan pag nagluluto tayo ng mantika or ilang beses natin ginamit na yung mantika may lasa na or maanta na. Tama ba yung term na yun? Maanta na. Okay? So if that is the case, you will say that the oil is already rancid. It's no longer fit for cooking. Okay, may lasa na hindi na masarap kumain. Usually, kaya masarap magprito guys kaysa sa nilaga kasi po, yung oil, nalalak niya yung flavor doon sa pagkain. Unlike sa sinigang, yung lasa o kaya sa nilaga, yung lasa nasa sabaw na. Kaya higop tayo ng higop ng sabaw. Pero yung karne, hindi na masyado malasa, di ba? Kasi nga, humalo na dun sa sabaw. Okay? Now, if you're going to compare the spoilage or the rancidity level, the polyunsaturated is has a greater chance of becoming rancid compared to the monounsaturated compared to saturated fatty acids. Okay? So usually, how do we prevent this? So usually, you enhance your fatty acid by reducing rancidicity. So you use antioxidant. Okay? Then you limit exposure of oxygen, heat, and light. Kaya di ba yung mga mantika, pag hindi na ginagamit, wag niyo i-stay lang dun sa sa may loob ng kawali. Kunyari, di ba, nagprito ka ng umaga ng itlog. Tapos medyo marami ka nilagay na mantika. Don't let it stay there. Tabi niyo po yon, takpan ninyo, o isalin niyo sa isang lagayan. Okay, you can actually use another container for your used oil. Ilagay mo siya sa loob ng refrigerator kasi nga kasama po dun sa mga factors natin is light and heat Okay? So, mas malilimit ngayon yung rancidity ng mismong oil niya. So, that is how you do that. And then, hydrogenation. So, usually guys, pag pinaprocess po kasi yung oil, hinihit yan. Okay? So, the more hydrogenation that it has undergone, the lesser chances it becomes rancid. Okay? So, yan. Kaya nga, as much as possible, if you're gonna be talking about yung, di ba sinabi natin kanina, essential oil yung alpha linoleic and linolenic acid, right? This is actually found inside olive oil. So, yan. So, olive oil is rich in essential fatty acids. Okay? So, kaya nga, the best niyan is, kaya if you're going to go to Italy, yung mga Italiano, mahilig sila sa olive oil. Lahat may olive oil. Kahit yung salad nila, yung vinaigrette. Yung vinaigrette, lalagyan nila ng suka, lalagyan nila ng balsamic vinegar, lalagyan nila ng olive oil. Tapos yun na, pagkain na yun, ulam na yun. Or yung tinapay, sasawsaw na nila doon, okay na yun sa kanila. Okay? O kaya yung tinapay, for example, meron kayong sourdough na tinapay. instead of placing butter in it. Yung iba nilalagyan nila ng garlic, kinakaskasan nila ng garlic, yung ibabaw. Okay? Tapos lalagyan lang din ng olive oil, tapos konting balsamic vinegar. Okay na yon. That's already good for them. That's healthy already. Now, if you're going to use cooking olive oil, kung light na luto, okay lang. Yung prito-prito konti lang. Pero if you're going to deep fry your chicken in olive oil, naku, ang gastos, ang mahal-mahal po ng olive oil. Pangalawa, again, more heat, PUFA again, olive oil. So, hindi maganda yon. If you're going to do deep frying, gumamit ka lang kayo ng coconut oil o kaya yung vegetable oil. Kasi po, since mataas ang heat pag nagdi-deep fry ka, mas madali siyang mag-rancid, di ba? So, mas maganda pag deep fry talaga is vegetable oil. Okay? So, yeah. This is actually according to one of a biochemist na pinag-aaralan yung mga fats. Okay? So, yeah. So, let's just have a quick review on those. Pag sinabi mong fatty acid, it's usually made of hydrogen and carbon. It is composed of carboxylic and a methyl group. Then it makes up your triglycerides and phospholipids. Then you have the saturated, which means no double strands. You have monounsaturated, one double strand, poly, two or more. Then you have mentioned also about linoleic and the alpha linolenic acid. And rancidity can be stopped by reducing it with antioxidants and hydrogenation. Okay? Yeah. So, any questions so far with fatty acids? Question, guys? None? FYI, guys, just to give you a heads up, as you will notice, medyo pahirap na tayo ng pahirap ng mga topics. So, ano pa lang, paunang salita pa lang, disclosure. Pagdating natin sa metabolism, ihandaan nyo na lahat ng inyong lakas. Kasi sinasabi ko sa inyo, hindi sa tinatakot ko kayo, pero medyo madugo po. Kung nagdugo kayo sa chemistry noon, mas madugo to. Okay? So, yeah. Okay, so since you don't have any questions, we'll proceed now with triacylglycerols or triglycerides. So when you talk about triglycerides, this is one of the family of lipids which is made up of three fatty acids and glycerol backbone. Okay, now it is most common lipid in food and body, and it makes up 95 of the lipids that can be found in foods. Yung taba, chicharon, yan, lipids yan, triglycerides yan. Now, functions ng lipids ay texture. Yan. Kaya nga 'di ba pag kumakain kayo nilalagyan ng para mas masarap yung karne pag piniprito, nilalagyan ng konting mantika. Yan. Okay? Then it also make the meats tender, preserves freshness, yes, and stores as adipose tissue in the body. Okay, so alin na yung mga taba sa katawan. Tinatawag na siya na triglycerides. Now, take note, although masarap po yung, alam mo yon, yung pag kumakain kayo, minsan lalagyan ninyo ng pinagmantikaan, ng pinirito yung kanin nyo para mas malasa siya. It should be always in moderation because high levels of this triacylglycerides or triglycerols will lead to heart diseases. Okay? Particularly yung pagkakaroon ng plaque buildup. Hindi yan plaque, guys, nakasangipin, ha? When I say plaque, this is build up. This is also the term that is used for build up all triglycerides in the blood vessels. Okay? Now, so you call it as acylglycerols or triglycerides. Now, again, as mentioned, you have three fatty acids that are esterified to glycerol. So the process of combining fatty acids and glycerol is esterification. Now, binibigyan ko na kayo ng heads up, you might see this in the exam. Okay? So, ang dami nating i-discuss na ngayon. So, lahat yan, marami tayong pwedeng kuhanan na tanong. Okay? Now, as I mentioned earlier, if it is solid at 25 degrees, which is the normal temperature, pag solid siya, you call it as fat. If it is liquid, you call it as oils. Okay? Now, they're the major source of energy for most organisms. It's usually 9 kilocalories per gram. compared to sugar, which is 4 kilocalories lang. Yun yung amount of heat na nare-release or energy. Now, these are the most reduced form of carbon in nature, which means the more energy is available in oxidation. Okay? So, these are now stored in our body as adipose tissue. So, pag kailangan natin ng, kunyari hindi ka kumain ng agahan, ng matagal na, alam mo yung nagpapapayat ka, kaya yung iba pumapayat eh, kasi kino-convert yung adipose tissue sa katawan into something that can be utilized by the body. Okay, so yung mga inipong ano nyo, mukbang dyan sa katawan ninyo, nawawala na yan pag hindi kayo kumakain kasi minametabolize na yan ng katawan. Now, another function of triacylglycerols is that they provide insulation and cushion to vital organs. So, when say insulation, guys, ito yung parang built-in jacket. Alam niyo, pag nagpunta kayo ng Baguio, yung mga payat, kiniginaw ka agad. Eh, paano kung walang jowa? Di wala kang kakapitan, wala kang insulation. So, yung mga chubby-chubby dyan, okay yan. Kasi they can wear light clothes. Medyo maninipis, okay lang. Kasi meron silang built-in jacket. Okay? Now, another one for vital cushion for vital organs. An example of that one is the pericardium of the heart. Okay? So, sa heart kasi, kinokavera niya ng, hindi siya yung taba talaga. May cover siya na taba. Okay? So, yun yun. So, when you look into a video of an operation, meron silang hinihiwa doon na white material covering ng heart. Yun yung pericardium. Okay? It isolates or provides cushion for the beating heart para hindi siya tumatama dun sa lungs, sa rib cage, yan. Okay? So, yan po yung trabaho niya. Okay. Now, here are examples of triacylglycerols, particularly yung simple. Now, why is it considered as simple? Is because you have here the same site or the same type of triacylglycerol. Okay, so isa lang yan. Okay, now, it can be formed in the storage of fatty acid for plants and animals. Yan. Now, compare it with this one. Now, this is a mixed triacylglycerol. Now, why it is mixed? Because it has three different fatty acids combined to your glycerol bone, okay, or glycerol backbone. Now, once you have a double bond, bumababa yung melting point niya compared to the one with purely saturated. Well, we discussed that earlier. Now, this is now myristil, stearyl, palmitoyl. That's gonna be the name. Kasi the moment it is already combined with the glycerol, hindi na po siya myristic fatty acid. It's gonna be, remember yung concept natin na pag name natin ng mga lipids, di ba? Yung alkyl, yung alkane, wait, just go back. Diba? Yung A and E, gagawin na natin siyang, ano ba yan? Okay, magiging YL. Okay, that's how you're gonna be naming it now. So, kanina, you have myristil. So, the name will be not myristic, but myristil, stearyl, palmitoyl glycerol. Okay, so that's how you're gonna be naming this. Now, kung yung kanina, let's say all of these are stearic acid. Okay, so this will be tristeryl glycerol. Okay, so ganun po yung pangalan niya ngayon. So that's 1, 2, 3 tristeryl glycerol kasi ito po yung backbone ninyo. Okay. Now, we have the other one, which is the phospholipids. Now, phospholipids is hydrophilic on one end and hydrophobic in one end. So, dalawa po siya. It has a hydrophilic end, so it is water soluble. The other one is hydrophobic or takot sa tubig. So, most of our cell membranes is usually made up of phospholipid bilayer. Okay? So, ito po yun. Choline is a different one. Choline is already a specific a protein that's added to the phosphate group. So ito lang po yung original na components ng phospholipid. Okay? Yeah. So example of that one is lecithin, also known as phosphatidylcholine, which is a major phospholipid in the cell membrane. And lecithin is also used as emulsifier in food. Wait lang guys ha. Wait lang. Hindi sumusuko sila. Okay, sorry guys. Okay. And then lecithin is also synthesized by the liver. Okay, so here is the structure of your phospholipids. Okay, so this is the structure. You have your two fatty acids here, you have your glycerol here, and then you have your phosphate. Okay, so this is now called as diacyl glycerol core. Okay, so ito yung mismong basic part. So this is your hydrophilic end, hydrophobic end. This one is your hydrophilic. Okay? So ito po yung ah, component na nakalabas sa cell membrane. Okay? So itong mga hydrophobic sila yung magkakaharap. Now, your triacyl glycerol that has a phosphate group. Now, this is now considered as your parent structure for phospholipids, and this is called as phosphatidic acid. Okay. Now, take note that it has a chiral center for the glycerol, and then usually for unsaturation, it is on the second carbon or the second position in glycerol. So if you look here, Kung dito, so and dito po, so lahat po na nandito sa carbon na to, ito po yung inyong unsaturation. Okay? Then the other one is unsaturated. Pero most of the time, ito. Now, pero may mga cases na meron po sa carbon number 1. Okay? So, yan. Okay, so this time, ito po yung structure ni lecithin. So this is, the name is phosphatidylcholine or common name is lecithin. So this is the part of the cell membrane. Okay, and then phosphate and then here is the choline component. Okay, dito po nagkakaiba yung iba't ibang klase ng cell membrane. Okay, yeah. So, yung iba naman po, ethanolamine, serine, inositol, and other glycerols. So, those are the things that can be different from one lipid to another. Okay, so here are your others. So, this is ethanolamine. So, this is ethanol and then amine. Okay, and then serine, ito po yung serine. Okay, sorry. And then here is your glycerol. So, you have another glycerol here. Okay. So, this is phosphatidylglycerol. So, dyan sila nagkakaiba, yung part na ito. Yan. And here naman is phosphatidylglycerol. Diphosphatidylglycerol are also known as cardiolipine. So, you have here actually two diphosphatidyl which is binded to a single glycerol. Okay? And this time, you have a sugar molecule which is inositol. Okay. Kaya ang pangalan niya is phosphatidyl inositol. Okay? Ito naman yung space filling model ng phosphatidyl inositol. Yan. So ito is puro straight chain. So this is what I mentioned about the second carbon is usually the site of unsaturated. So yeah, so here is this is straight chain and this is a unsaturated. Okay, so this is stearic acid dahil straight chain dahil saturated siya. Then the second one is oleic acid kaya ang pangalan niya is oleol. So here is the name. One glycerol, one steroil, two oleoil, phosphatidylcholine. Okay, so ito example niya. Now take note that ether containing glycerophospholipid possess an ether linkage instead of an acyl group at the C1 position of the glycerol. Now there are two types of glycerols or the two types of this compound. We have plasmogens and platelet activating factors. So plasmogens are ether glycerophospholipids in which alkyl chain is unsaturated. So ito po yung itsura niya. Okay, so this one, ito yung ester linkage. Then yung isa na po is ether linkage. Okay? Yan. So, one alkyl, two acyl, phosphatidyl ethanol, amine, or ethanolamine. Okay? So, yung R, yung rest ng group yan ha, or rest of the sugar. Okay? So, pag hindi po siya ester, pag ether po yung R1 niya, it's considered now as a plasmogen. Okay? Now here, yan. Ito naman, phosphatidylcholine na siya, hindi phosphatidyl. Kaya phosphatidal kasi nga po, it's because of the plasmogen here. Okay? Hindi po siya ganito. Dapat ganito siya, di ba? For phosphatidyl or phospholipids, ito dapat. Pero once na naging ganito na siya, it's called now as a plasmogen. Okay? And this is now your phosphatidylcholine. Okay? So this is the choline component. And this is the plasmogen part. Now take note that this is cis structure. Okay? Now, platelet activating factor can also have an ether glycerophospholipid. Now, the function of PAF or platelet activating factor is as a potent biochemical signal molecule. Usually, it's involved in reducing inflammation, lowering blood pressure, and platelet aggregation. Now, this is needed when you're undergoing blood clotting. Okay, yung platelet activating factor. Now, the short acyl chain in C2 position in PAF makes it more soluble. And phospholipids in general are the major membrane components. Okay, so this is what the PAF looks like. Okay. Okay, so this is still a choline. Yun nga lang yun to. Ito po yung activating niya, which is the acetyl part. Okay, yeah. So take note here, you're looking at your cell membrane, cross section of the cell membrane, and inside the cross membrane of the cell. Okay, wait lang guys. Okay, so here you have here your lipids. Okay, combined together. Okay, so as I mentioned earlier, yung magkakapareho, yun yung magkakaharap. So you have here your lipids, your hydrophobic ends or your tails rather. So it's a two-tail hydrophobic phospholipids, and you have your hydrophilic or your water-loving. So lahat ng water-loving, yan yung nakalabas sa cell at nasa loob ng cell. Okay? Kasi nga, yung cytoplasm is liquid in nature. It contains water, kaya doon po siya nakaharap. So lahat po ngayon ng mga lipid tails natin o yung mismong water-hating natin ang magkakaharap. Okay. Now, in between each phospholipids, you have a cholesterol to maintain the fluidity. Otherwise, magiging matigas po yan. Okay? So, yan. Now, there are two general types of phospholipids. You have glycerol base or sugar base. Okay? And, sorry, glycerol base rather, sorry. And then sphingosine. So, yung backbone natin, iba na po ang itsura kanina. Nag-start tayo ng glycerol. Tapos yung isang glycerol, instead of having another tail, ginawa nating lipids or phosphate group rather ang nakalagay instead of fatty acid. Now this time, yung isang fatty acid, we will have now yung sphingosine. Okay? Now, kanina glycerol with phospholipids, yun yung glycerophospholipids natin. Now, this time, yung sphingolipids naman, okay, include phosphorylated and non-phosphorylated compounds. So, the backbone now is sphingosine, which is an 18-carbon alcohol, which is the backbone of this one, instead of glycerol. Okay? Now, the fatty acid is joined to the sphingosine using an amide bond or amide linkage, and it's called now as ceramide. Now, example of ceramides are usually picoline, phosphate choline, and some of it are phosphate ethanolamine at the C1. Okay. Then you also have glycosphingolipids. When you have glycosphingolipids, your sphingolipids has a sugar molecule. Now, take note that it's usually beta linkage on the 1-hydroxyl group and there's no phosphate. So, ito po yung mismong compound natin ngayon. Okay? So, this is your sphingosine. So, take note that this is a trans double bond kasi nga nasa transverse position. Okay? So, this is an 18-carbon alcohol, yeah, because of this. And usually, this is coming from palmitoyl coenzyme A and serine. Now, once na nilagyan natin ng sugar, it becomes now a ceramide, particularly on the amide linkage. So here, ito na po. Ginawa na nating active yung amide linkage here. Ito na ngayon si ceramide. Okay? So ito na po yung addition natin. Now, a phosphate esterase on carbon number 1 forms a ceramide phosphate. The head group is esterified to the ceramide phosphate yields the sphingolipid. So, common na sphingolipids is choline and ethanolamine. So here on the next one, ito po yun. Okay? So you have here your sugar, ay sorry, not your sugar, your fatty acid na naka-combine siya dito. Yan. Okay? And this is your choline. Okay, so this is now your ceramide or your ceramide with a phosphocholine head and is known as the sphingomyelin. Okay, now sphingomyelins are components of the myelin sheath. So myelin sheaths is needed in the cell, in the nerve membrane. Okay, um, ano ba tatandaan natin sa nerve membrane? Usually it allows easier transport of information from one nerve cell to another. Pag nagkakaroon tayo ng demyelination, yung nerves ngayon nawawala yung impulse. Kaya it's either sumasabog yung impulse or hindi nagkakaroon ng impulse communication because of demyelinization. Okay? So yan. Now, glycos phosphorus glycosphingolipids are not phospholipids. So this is not does not considered as a phospholipids. So yan ang tatandaan ninyo ha. Now, cerebrosides are the ones that contains only one sugar molecule. It's either you have a glucose or galactose. Pag if it is glucose, you call it as a glucocerebroside. If it is galactocerebroside, it is attached to a galactose sugar molecule. Okay? Now, let me just quick reminder, pag sinabi mo kasing glucocerebroside, another function of glucocerebroside is, wait, guys. Yan. It is actually found in macrophages, which cells that do not that protect the body by ingesting and destroying foreign microorganisms, while galactocerebrosides is almost exclusively in the membrane of brain cells. Okay, so yeah. Then gangliosides, ang kinaibahan nito sa cerebrosides is isa lang ang sugar. Ito, three or more. Okay? So it is also, one of them is sialic acid. Now, this is used in signal transduction and immunology. So here is an example of a ceramide. Okay? Now, take note that there is a beta-glycosidic bond. So, yan o. Pag nasa taas, di ba, yung OH, it's beta. So, yan yun. Okay? And then, it does not have any phosphate group within this compound. Okay? So, this is beta-galactose. So, this is not beta, but galactocerebroside ang pangalan niya. So, a galactose and a cerebroside is galactocerebroside. Now, gangliosides are important components of the muscles and nerves membrane. Now, there are actually 50 components. Now, take note that it is also beta linked to the ceramide. Okay? So, ito yung ceramide component. Ito po yung mga sugars na nakakabit doon. Okay? So, galactose, glucose, and then sialic acid. That's GM3. Pag nilagay niyo po yung N-acetyl galactosamine, you have GM2, and then GM1, it's including another unit of galactose. Okay? So, this is an example of, ito po yan. Pag ginawa nating space filling, itong buong ito po yung itsura niya. So, ito yung GM1. Okay? Okay, next is waxes. So waxes are actually long chain alcohols that are esterified to long chain fatty acids. And an example of that one is beeswax. Now, beeswax is made up of triangcontanol palmitate. Okay. Now, take note, it is an ester. So, general formula of wax is RC double bond O O R. Okay? Now, pwedeng ito po yung isang side mo is fatty acid and another fatty acid. So, an example niyan is oleol stearate. Okay? So, oleic acid yung isa, and then stearic acid. Then you have stearyl palmitate. Ito yung stearic acid. And then ito yung palmitate N. Okay? So, yung triacontanol is triacontinyl. Ha? Ano ba yun? Triacontanol palmitate. So, yan, you have palmitic acid here. Okay? Yan. Next one. Yan. So, it is actually, when you talk about waxes, this is insoluble in water because of the hydrocarbon composition. Take note yung kanina, mahaba yan. Pag mahaba yan, it is again not going to be interacting with any form of water. Now, usually animal skin and fur are coated with wax, and that is why it is water repellent. Yung mga leaves ng plants and birds are also water repellent because they have wax. Di ba pansin niyo yung yung mga dahon ng malunggay, dahon ng saging, di ba? Kaya nga di ba, I'm not sure if you've encountered this in the olden times, nabutan ko kasi ito eh, nung panahon, nung mga katandaan, pag nagpa-plancha nun si Lola, meron siyang pinapatungan niya is dahon ng saging. Okay? Kasi po, yung dahon ng saging has also wax, di ba? So yung wax po niya, pag iniinitan po yung dahon ng saging, nare-release yung wax, yun yung sinasabay sa pagplancha ng damit. Okay? Para po makinis, madulas, hindi basta-basta kinakapitan ng alikabok. Yan ang mga turo ng mga nakakatanda noong unang panahon. Okay? Now, carnauba wax is actually one of the favorite materials that's used in finishes ng mga boats, kotse, sahig, at saka sapatos. Yung Kiwi, guys, is a brand that sells shoe waxes. Okay? Ginagamit nila po is, dalawang po klase yung Kiwi noon. Ang naabutan ko is yung talagang hard na material, no, kailangan pa ng basahan. Like yung old school talaga na pagwawax. Kukuha ka ng basahan, magkukuha ka ng konti ng paste, ipupunas mo sa sapatos mo. Tapos, pag natuyo na siya, iba-brush mo siya. So, very, very slick talaga, makintab. Iba naman po yung mga charol na sapatos, yung talagang makintab yun. Pero pag sinabi mo kasing gawa sa leather, you need to apply wax on it to maintain its uh, condition. Okay? Tapos yung sa bumasok naman ngayon, yung isang ginawa ni Kiwi, na kung saan it's a liquid. Kung makintab siya, guys, yes. Pero ang problema naman doon is hindi siya ganun katagal. Tapos pag nabasa na siya ng tubig, parang hindi na siya ganun kaganda. Unlike yung carnauba wax, yung talagang old school na shoe shine talaga na wax, mabasa man hindi agad-agad natatanggal yung wax niya eh. Yung sa kiwi na liquid, hindi eh. Lagyan mo nga siya, makintab siya, pero after a few days, wala na kagad siya. Kailan ako nababasa. Then we have another one is lanolin, which is actually a wood wax which is used for cosmetics like olive oil. Okay? Then ginagamit din to sa lipstick yan. Okay? Then another classification of lipid is terpenes. Okay, so this is actually made up of combination of isoprene units. Now, isoprene is actually 2-methyl 1,3-butadiene. So double bond butane. Okay? Now, it's further classified based on the number of units. You have monoterpene, sesquiterpenes, diterpene, and then you have also yung poly. Now, monoterpenes usually carbons of 10 only. Okay? So, dalawang units ng isoprene. So, ibig sabihin, yung isoprene is 4 to 5 carbons yan based on this structure. 5 carbons yan. Then sesquiterpenes, it's 3 isoprene units, kaya 15 yung carbons niya. Then diterpene has 4 isoprene units. So since 5 ang isa, kaya 20. Now steroids is actually a derived from terpene. This is actually an alcohol already. Then biological precursors of these lipids are isopentyl pyrophosphate, dimethyl allyl pyrophosphate rather than isoprene. Okay? So here are some examples. Now take note that for terpenes, you have a head and a tail. So yung head are usually this one. Okay, yung isang double bond and the other one is a tail. Kaya mapapansin nyo wala na po dito kasi hydrogen yan. The only thing that is gonna be shown here is if it has a carbon. Okay. Now, in terms of polymerizing your isoprene, pwede siyang head-to-tail linkage like stand for geranyl or tail-to-tail linkage. Okay. Now, isoprene can also be distilled from natural rubber, which is a linear head-to-tail isoprene units. Okay. Yeah. So here, example of monoterpenes, you have limonene, citronellal, methanol, campine, and pinene. So these are actually flavors or odors. So this is for lemon, citronellal for roses and perfumes, menthol, yung ginagamit natin sa ubo, camphor, and pine. Okay? Then you have also sesquiterpenes, bisabolin, eudesmol, yan. And then you have diperterpenes, you have pitol, gerberelic acid, and all-trans-retinal. Yung all-trans-retinal, which is actually the visual pigment in rhodopsin, yung sa mata natin. And then phytol is for chlorophyll. And then this is a plant hormone. Okay? Then you have also yung triperterpene. So you have three units here. You have their lanosterol, which is a component for wood fat, and also the component or precursor. We say precursor, guys, this can form cholesterol and other steroids. Kumbaga siya yung parang parent form, tapos mutate niya into other compounds. Then you have also squalene. Okay, ito antioxidant din po ang squalene eh. And then you have also lycopene, which is a carotenoid found in tomatoes. Okay? Then ito naman po yung sa alcohol. So this is sterols, which is more complex than phospholipids and triglycerides. Okay? It usually this is connected with rings and hydrogen. It does not provide energy. Now the best known sterol is cholesterol, which is found in every body, helps in body processes, and then phytosterol, ito naman yung plant cholesterol niya. Okay? Or major plant sterols. Okay. Now, steroids are usually polyprenyl, okay, molecules built with a core structure of three six-membered rings and one-membered ring, all fused together. So take note of this. This might come up in your exam. Now, as I mentioned, cholesterol is the most common steroid in animals, and it's also a precursor for other steroids in animals. So, pwede siya maging bile, lanosterol, yan. And then, it can also have functions like salt balance, metabolic function, and sexual functions. Later on, you will see the why. Okay? So, again, looking at the structure here, yan. Ito yung fused na ring structure. Tatlong six chain or six-sided carbons and then isang five carbons. Okay? Excuse me. Now, here's another byproduct of cholesterol, bile acid. Now, this is C24. So, 24 units of carbons inside. Now, it's usually including cholic acid and deoxycholic acid, which is both of them, ito part ng bile yun, is function as a detergent molecule. Okay, so what happens is that when you eat lipids, okay, let's say, or fats, lechon, okay, yung taba ng lechon, o kaya, di ba sa bulalo? Sino dito nakakain na ng utak ng bulalo? O nakakain ng bulalo? Okay. Michael, Daniel, okay, ano yung nasa loob ng buto ng bulalo? Ha? Describe nyo nga. Bone marrow. And bone marrow is rich in fat. Okay? So, let's say kumain si Michael ng bulalo. Hinigop niya. Ganon. Okay? Yung mismong bone marrow. Now, it doesn't usually get broken down right away. Kaya na nguyain pa niya yon. Eh, medyo malambot-lambot yun eh. Kasi malambot yun eh. Ilang oras yun pinakuluan sa apoy, hindi siya ginamitan ng gas. Usually 'pag nagbubulalo kayo guys, gamitan yung iba ginagawa, ah, hin ano, pinakukuluan nila talaga, hindi po puwedeng pressure cooker. Kasi po 'pag pressure cooker daw sabi ng iba, although mabilis maluto lang daw yung karne, pero mas malasa kasi 'pag pinakuluan mo ng matagal yung bulalo. Kaya yung iba, gumagamit talaga ng kalan de uling or kalan na kasing kahoy talaga yung ginagamit nila para siguradong matagal. So if you're going to go to Tagaytay, yan, sarap ano yun, sarap humigop ng bulalo doon, 'di ba? Okay. So what would happen is that the biles would tend to break down this fatty globules, yung mismong buong bulalo na hinigop neither ni Daniel or ni Michael, into smaller ones, okay? Inatanan nila, kinagat na nila, pero it's not enough to break it down faster. So, kailangan ng bile. So, yan. The bile is usually created by the liver and it is stored in the gallbladder, okay? So, yan. So, pag kailangan na siya, isisikret siya ni gallbladder into the intestine, sa small intestine. Doon tayo nagbe-breakdown yan. Hindi sa stomach. Okay? Walang reaction sa stomach. 'Di ba? Ang in reaction lang is proteins. Pero yung mga carbohydrates, yung mga lipids, lahat sila sa small intestine nagre-react. Okay, so that is the structure of cholic acid and deoxycholic acid. Okay, next is cortisol. So this is a 21 carbon adrenocortical hormone that controls the level of carbohydrate and protein and lipid metabolism. Okay, then you have also progesterone, which is the precursor of estradiol and testosterone. So this is actually needed. This is actually sex hormones already. Okay, then you have here testosterone. O, sa mga lalaki lang to. This is a primary sex steroid hormone. Kasi nga galing sila sa steroid structure. Yan. So, binago lang. So, if you will notice, yung progesterone kasi, yan. Ito po yung original. So, it's broken down or further developed to form testosterone and estradiol. So, if you will notice, ano pinagkaiba nitong dalawang to? Ito, tatlo yung double bond. Ito, isa lang po. Then the other one is oxygen. Yung isa naman is hydroxide. So, yun na ang pagkakaiba nila, di ba? Okay? So, yan. Now, glycerophospholipids and sphingolipids play important roles such as chemical signals in and on cells. Now, lipid signals act locally either within the cell or cells near cells near it. Okay, usually they can initiate a cascade reaction with multiple effects, and these signals usually are gonna does not last long, and creation and breakdown of lipid signals as carefully regulated and timed. And some of the reactions that produce these signals are shown in the next slide. So here, usually your glycerophospholipids are broken down to this type of products. You have arachidonic acid, lipophosphatidic acid, diacylglycerol, inositol phosphates, or yung PIP2. Okay, so ito po yung mismong pathway nila. So you have phosphatidic acid with PLA2 would be broken down to arachidonic and LPA. Then your arachidonic acid is further broken down to or can be formed now prostaglandins, thromboxanes, and leukotrienes. And that's how it's going to be affecting the body with these ones. Okay. Then you have also phosphatidylinositol. Okay, so this will be broken with the action of ATP, it will form PIP2. Then afterwards, it will form now the acylglycerol and inositol 1,4,5 triphosphate. Now, this diacylglycerol would be precursor in signaling other pathways, while the other one is more on binding and regulation with the increase of cellular calcium ions. Okay? So, yan, this is how it's going to be affecting it. Now, don't need to dwell on this one. We will be working on this when we go to metabolism. Now, since we mentioned about prostaglandins, thromboxanes, and leukotrienes, These are actually under the classification of eicosanoids. Okay? Now, these are unsaturated C20 fatty acids. Now, ano yung functions niya? It can lower down blood pressure, smooth muscle contraction, prevent contraception, produce fever, water retention, electrolyte balance, and inhibit fatty acid breakdown. Okay? So, ano-ano ba yung mga yon? Ano ba, sino-sino ba doon? Okay? Unang-una po, si blood clotting. Okay, hindi nakasulat yan, pero kasama po si blood clotting. Plant, uh, blood clotting or thromboxane A2, ito po yon. Okay? This is the one responsible in producing, this is actually produced by platelets in the blood, and it stimulates constriction of the blood vessels and aggregation of the platelets. So for example, nasugatan ka, si TXA2 siyang responsible for contracting, sorry, not contracting but constricting yung blood vessels. Kumbaga pipigilan niya yung blood flow. Okay? Tapos, opposite din niya is PGI2. Ito, prostacyclines. Kung ito nagko-constrict ng blood vessels, ito hindi. Siya yung opposite na trabaho. So, it has to be a balance of these two. You have PGI2 is actually responsible for blood dilation or blood vessel dilation. So, ino-open niya yung blood vessels, lalo siyang magdudugo. Okay? And it prevents blood clotting. So, magkalaban tong thromboxane at prostacyclines. Okay? So, yan dalawa. Okay? Next is also inflammatory response. So, for example, meron kang sugat, and then one of the main effects is swelling, fever, and pain. Kaya nga, di ba, pag sinabi mong prostaglandins, the first thing that usually comes into mind because of an advertisement before is pain chemical. PGF2, prostaglandins. Ito po yung iba't ibang mga prostaglandins. Okay? Now, the prostaglandins promote certain aspects of the inflammatory response. So, usually, para ma-minimize mo yung inflammatory response, okay, yung lagnat, yung pamamaga, you take in medication. So, isusuppress mo itong action itong mga to. Okay? Yan. Then, sa reproductive system, yung PGE2, ito, okay, it actually stimulates smooth muscle contraction during uterine wall ejaculation of the egg. Not the egg pala. Not, pag-release na pag nanganganak, ito yon. This is the one responsible for birth. It actually allows it to go out, yung i-expel yung mismong yung fetus from the uterus. Okay? So yan. Now, bakit yung mga girls may dysmenorrhea? Because of high level nito. Okay? So, pag mataas ang level ng PGE sa katawan, may dysmenorrhea. Okay? So, usually it's in the balance of food and diet yan. Okay? Next is, sa gastrointestine naman, it actually, saan ba yung PGE? PG. Okay? Hindi ko naman ako dito. Basta one of this one, yung PG or prostaglandin, sa stomach naman, it increases the secretion of mucus layer in the stomach. Kasi yung mucus layer, guys, it actually protects also the stomach lining para hindi siya maapektuhan dun sa acidity ng stomach. Okay? Yan. Then, yung isa sa kanila, I forgot which one is it. Basta, pwede din siyang mag-inhibit naman ng secretion. It's always magkalaban eh. Okay? PGF2 yata and PGD2. Okay? So, yung isa nag-release ng mucus, yung isa naman binabawasan ang mucus. Okay? Now, take note, mucus helps by inhibiting acidic action on the stomach. Next is kidneys. Yung PG naman, o yung prostaglandins in general, actually increases renal blood flow in the kidneys. Now, if there is an increase in renal blood flow, definitely it's gonna increase water and electrolyte secretion. Maiihi ka dahil dyan. Okay? So pag mataas ang prostaglandin sa may renal area, do sa mga kidneys, malimit kang maihi. Okay? Now, in the respiratory tract, yung leukotrienes, ito, okay? Yan, yung mga yan. Now, this is the one responsible in constricting the lungs bronchial muscles. So, for example, let's say, meron kang naamoy na kontra sa katawan mo. Yung pala allergic ka sa pollens. Okay? So, ano nangyari? In-inhale mo, ayan na, meron ka ng allergic reaction. So, it's actually the leukotrienes that will constrict your bronchial muscles. Okay? And then, the prostaglandins will be the ones responsible for dilation. Okay? So, yan po yung nangyayari dyan. So, yun yung mga function nila. Now, sphingosine can be broken down to, or can be broken down to produce chemical signals. Okay? So, example of that one is sphingosine 1-phosphate. Okay, this actually be excreted by the cell and it can bind to cellular membrane receptor proteins or to adjacent proteins from where it is released. So, ito yung S1P. Okay. Now, let's go now to the complex, the lipoproteins. So, here. So, usually we have chylomicrons. Now, chylomicron is a form of lipoprotein which is too large to be, that actually helps in the absorption of lipids, particularly those that are too big to be absorbed directly in the bloodstream. So, usually, ang ginagawa niya, ito kasi ito, hindi siya nakapasok diretso sa bloodstream kasi nga sobrang laki niya. It can enter the lymph nodes or the lymph pathway or the lymphatic pathway. Tapos after nun, saka siya papasok sa blood vessels. Okay? Yan. Now, so usually if it's a small or medium chain fatty acids, it will be entering the circulatory system. But if it's too big, it has to combine with phospholipids and cholesterol, forming chylomicrons before it enters. So, ito yung nangyayari dyan. So, kung maliliit lang, diretso sa blood vessel. Pero kung malalaki, it bypasses the blood vessels, lymph system ang daan niya. Tapos napunta sa liver, saka siya makakapasok sa blood vessels. So, this is the way it enters the blood system. Wait lang guys, water break lang. Okay. Okay. So now, lipoproteins tend to transport. So this is how it's actually inside na. So nakapasok na tayo, di ba, sa lymph nodes, sa lymph and the bloods. Now this time we're gonna be talking about the different lipoproteins. Okay. So you have the chylomicrons, sabi natin kanina. Then you have also the VLDLs, the LDLs, and the HDLs. Okay? So yan, LDLs. So ano yung pinagkaiba nila? Usually, it's actually based on the number of components, kung gaano karami sila sa loob. So most of the time, these are globule molecules with lipid center surrounded by plasma membranes. Now, usually, it depends on the density for its function. And the higher the protein, the higher the density is. So here is a comparison of the ratio of your different proteins. So you have your chylomicron. If you will notice, 90% of chylomicrons are triglycerides. Okay? LDL has 25% protein, 10% triglycerides, 50% phospholipids, 50% cholesterol. Okay? Then here, HDL, 50% protein, 25 phospholipids, triglycerides 5%, cholesterol is 20%. While VLDL, very low density lipoproteins, this is 60% triglycerides, 10% protein, 18% phospholipids, 12% cholesterol. So, Based on this, we can actually remember you might have already heard about bad cholesterol, good cholesterol. Ito po yun. Ito po yung basis na yun. So if you're going to look at this, ito po yung mga explanation yan. VLDLs tends to become LDLs, yung low density lipoproteins. And these low density lipoproteins are actually the bad cholesterol. Kasi kaya siya bad, kasi po yung kanyang cholesterol amount is 50%. Okay? While the other one, yung HDL, kasi yung cholesterol niya is 20%. Although konti lang yung sa 12, kaya lang nga, di ba? Yung VLDL, pwede siya maging LDL, pero hindi siya magiging HDL. Okay? So, yan. Well, HDLs are considered as the good cholesterol. So, ito yung mga chine-check sa atin when we have test sa lipids sa profile ng dugo ninyo. So usually if it's high HDL and LDL, so pag mataas ang LDLs mo, it means you have a high cholesterol, bad cholesterol. Pag HDL ang mataas, you have a high good cholesterol. Okay? Now, ano ba yung function nila? Yan, ito po yung ginagawa nila as a transport. Okay? So for VLDLs, they deliver fatty acid made from the liver into the cell. So dinideliver niya. Okay? Now, usually when you have fatty acids, kunyari marami kayong mga kinain, it's usually converted by the livers into fatty acids. And then they deposit it into the different body cells. And usually, saan yung pinakamalapit na body parts na pinagde-deliveran ng VLDL? Anybody who could guess saan yung unang-unang pwedeng lagyan ng fats ng VLDL? Anyone? Saan una dinadala? Pinakamalapit sa liver. Anyone? Hello? Wala. Sa tiyan. That is the first one that is going to be deposited. Kaya mapapansin niyo, for those who are getting fatter, the first place na lagi tumataba muna ay yung tiyan. Then later on, pag medyo makapal-kapal na sa tiyan, ay puno na dito. Let's expand to the horizon. Kakalat na yan. Pwede na padala sa may braso, sa hita, sa puwet, hanggang magpantay-pantay na yung fatty acid sa all over the body na. Okay? Now, yung LDL naman po, siya naman ang nagdadala ng cholesterol. Okay? From the liver towards the different parts of the cells. And including po yun yung arteries na de-deposit yung cholesterol along the arteries. Kaya nagkakaroon ng plaque yan. Okay? Na naiipon yung cholesterol sa blood vessels. Okay? So from the liver towards the different body parts. So ang pagkakaiba nila, VLDL, fatty acid ang dinadala. Ito naman si cholesterol. Now, si HDL naman, siya naman ang nagtatransport ng cholesterol from the body cells at binabalik niya sa liver. Okay? For further reaction or disposal. Okay? So, kaya nga mas maganda na mas marami tayong HDL na dini-intake kasi po, siya yung tutulong para matanggal yung mga plaque sa loob ng katawan natin, yung mga cholesterol na nag-build up para papunta sa liver. Okay? So, yan po. Any questions so far, guys? Pero ayaw niya sumagot. Anyways, so just a recap, things to remember, you can just go over this one. Yan. Okay, kayo na lang po magbasa nito. Medyo mababa na po discussion natin. Let's go now to the functions, okay? So as usual, as I mentioned earlier, your fats and cholesterol has this major function: source of energy, form of body structures, diba, cell membranes, regulate metabolism, enhance absorption of fat-soluble vitamins, provide insulation to regulate body temperature, and cushion major organs. So as I mentioned earlier, usually fat provides 9 kilocalories per gram compared to sugar, which is only 4 kilocalories. So twice. Now, if in case kailangan na ng katawan mo, dyan siya magagamit. Pero usually it's going to act as reserve. Okay? So pag yung mga tumataba dyan, nasosobrahan na daw tayo ng reserve sa katawan niya. Okay? It's time to use it now. Okay? Next, fat has an unlimited ability to store excess fat as adipocytes. Okay? Take note, ganyan ka na, ano siya, yung capacity is up to 1,000 times its original cell. Yan. Yan ang dahilan kung bakit tayo nagsisilakihan. Ba't naglalakihan yung iba? Kasi nga, it can enlarge itself 1,000 times from the original size. So, imagine mo lang, yung enlargement na lang to 1 to 1,000 magnification. Ang laking bagay na yon. Okay? Yan. And body has the ability to produce additional fat cells. Ano ba yan? Kasalanan din ng katawan natin yan. Okay, next. Fat is used as energy to help absorb lipid compounds. Yan. So take note that it is the preferred source of energy for heart, liver, and muscles. And it cannot sustain life alone. It needs glucose. Okay. Now we will go into that one when we go to gluconeogenesis. Now, take note that if in case you are payat, usually they suffer from fat dietary diseases or fat-related diseases. Okay? Yung mga skin diseases. Kaya mamasin nyo ibang mga payat ang dry-dry na skin nila. Yan. Okay? Because they lack also the needed body fat to absorb. Okay? So, kailangan meron taba sa katawan para mag-absorb ng taba. Okay? Yun ang ibig sabihin yan, which is true naman talaga. Then 20 grams per day are needed to stimulate chylomicrons to transport fat-soluble vitamins. So at least 20 grams daw per day ang fat mo para magkaroon ng transport ng fat-soluble vitamins. Okay, so this is what I mentioned earlier. It, the fats in the subcutaneous tissue insulates the body, maintains body temperature. Okay, yan yung built-in jacket. And it also protects bones and vital organs from trauma. Okay? Pag nasobrahan ka naman ng payat, yung protection do sa mga vital organs mo, nababawasan din. Okay? Then, for nutrition, you have linoleic acid as one of the essential fatty acids kasi it can be elongated and converted to arachidonic acid. Then, alpha linolenic acid is converted to eicopentanoic acid or EPA. And EPA elongates to DHA. Okay, DHA narinig nyo to sa sa utak, 'di ba? Yan. And this is needed for healthy cell membranes. And EPA and arachidonic acids are used for manufacturing eicosanoids. Now, eicosanoids are hormone-like substances that produces prostaglandins, thromboxanes, and leukotrienes, which regulates the immune system, blood clotting, inflammation, and blood pressure. Now, cholesterol is used to make bile, hormones, and vitamin D. So, it's a part of the cell membrane, it's precursor of vitamin D, a precursor of bile acid, and precursor of sex hormones such as estrogen and testosterone. Okay, so yeah. Okay, so this is just the summary of what we discussed. Okay, yeah. Any questions so far, guys? Questions? None? Wala na naman sila. Anyari na. Okay. Time out na daw. Okay, so if you have no more question, I'm going to sing it on si Professor Dave. Okay? Wait lang. Where are you? Hala, tagal.